And here we are working on 4C from the green worksheet 8.8. First thing I notice is this is a giant division problem, and what I'm going to do is I'm going to take this numerator, just going to write it out separately. This is 1 over x minus 2 plus 1 over x plus 2. That's that numerator. And they want us to divide by this one on the bottom, which is x over x plus 2 minus x over x minus 2. Okay, so let's figure out what these two are separately, and then we'll do the whole same change flip. We'll keep the red one the same, we'll change it to times, and we'll flip the blue. But before we do that, I want to get these combined into one fraction, both red and blue. All right, so again, just for clarification here, we're taking this whole thing divided by this whole thing. Okay. Don't do any flipping yet. First, let's try to get a common denominator. So in red, the fraction on the left has an x plus 2. The fraction on the right has an the fraction on the left has an x minus 2. The one on the right has an x plus 2. So we need a common denominator. So basically what happens here, this denominator needs to be shared over here and up top. And then the x minus 2 needs to be multiplied here on the bottom and top. So it ends up looking like this. Let's let all that blue stuff clear. We're going to take this x plus 2 and put it on the top and the bottom. Plus, we'll take this x minus 2 and put it on the top and on the bottom with the x plus 2. So now we have a common denominator in red. Let's continue with the red fraction just to clean it up. And what do you notice? Well, we're adding on the top x plus x, which is what? 2x, and 2 plus negative 2, which is 0. So that's gone, and you just have this. All right, so that's what the red fraction ends up equaling. We're still dividing at this point because I'm not flipping what's in blue. Let's clean up what's in blue. Again, we have this denominator on the right that we're going to share with the denominator on the left. So we need an x minus 2 on top and an x plus 2, x minus 2 on the bottom. This is basically a fancy form of the number 1 that we multiplied by. So we're not changing the value of that fraction, we're just changing how it looks. Minus this x in the numerator will be joined by this x plus 2, because we're looking for that common denominator again. You may hear this called, as you move forward in math, a fancy form of 1, x plus 2 over x plus 2. So you're doing that to get this balance, this common denominator here, so that we can subtract. All right, so we still have divided by for now. And this blue fraction is going to end up equaling, well, we have x plus 2 times x minus 2. That's the common denominator. And let's clean up the numerator. I'm going to write it in green first, right above this. If I distribute that, it's going to be x squared minus 2x. If I distribute this x, it's going to be x squared plus 2x. Take a moment to reflect on that. And then take a moment to think about the fact that we're subtracting these. All right, you're subtracting both of those. So we have x squared minus x squared. It's gone. And then you have negative 2x minus 2x. That's negative 4x. So now we're taking the red fraction divided by the blue. And what I was always taught was to keep the first fraction the same, change the time sign, change the division sign to a multiplication sign, and flip the second fraction. And look how everything plays out right now. We're multiplying, we have this big fraction bar. Do we have any complete matches in the top and the bottom? I'll show them in green. This x plus 2 will cancel with this x plus 2. This x minus 2 will cancel with that x minus 2. And finally, this little x will cancel with this little x. That's legal because everything is being multiplied up there. 2 times x over negative 4 times x, the x is canceled. So all that's left is a 2 on the top and a negative 4 on the bottom. That reduces to negative 1/2. So that big mess of an original problem at the top ends up equaling negative 1/2. If you take a couple numbers and plug them in, it should work out. Plug in some numbers like 8 or 6 or 5 or anything but 2 or negative 2. Why wouldn't you want to plug in 2 or negative 2 to check? You get 0, which is going to be an undefined answer. Okay? But if you plug in any other number other than those, it should work out, no matter what number you plug in, to equal negative 1/2.